Welcome to Quadratics Part 10 in our series. What I've done here is I've created a really challenging, unusual sort of question that will really test your understanding of particularly completing the square, even though that isn't mentioned explicitly in the question. Okay, so we've got the general form of a quadratic equation here, and we're presented with this thing here where x is a function of itself, okay, and we've got to rearrange it into the form p brackets x minus q all squared minus r equals 0, okay, where we've got to find the values of p, q and r. And they're rational numbers. That means they can be integers, they could be negative, and they could be fractions, okay, but they can't be surds. They will be rational numbers, and hence find the values of x that solve the equation. Now, the clue that it's a completing the square problem is the way that this is set out here, and we've got to convert that into that. So how do we go about it? Well, let's make a start. And I'm just going to look at that and say, well, I'm going to multiply both sides by the denominator. So I'm going to start by writing I'll just start with the question as it is. So it's 1 over, okay, 5 minus 2x equals x, okay. Multiply both sides by the denominator to give me that 1 equals x brackets 5 minus 2x. Okay, so all I've done is taken the denominator from the left, multiply both sides by that to give this. Now, because it says show that here, it's important that all the steps are there. You can't just jump straight to the conclusion without showing sufficient working. All right. Now I'm going to multiply out the bracket. Okay, and I get 1 equals 5x minus 2x squared. Okay, and it's starting to look like a quadratic, because what I can do now, of course, is I could take away 1 from both sides and have 0 equals 5x minus 2x squared minus 1. All right. Now, it's preferable to have a positive x squared term. So what I'm going to do is I'm going to multiply both sides by -1 and put this to the left. So basically everything that's negative here becomes positive and vice versa. So I can say that 2x squared, okay, minus 5x plus 1 equals 0. Okay, now it's starting to look like well, it is looking like a quadratic because it's now in that form, but it also therefore means we can complete the square, and that's what this is looking like doing. I'm going to take out the 2, okay, and I'm going to say that this means that 2 lots of, okay, x squared minus 5 over 2x, okay, plus a half, okay, equals 0. So I've taken out a factor of 2 from the whole thing. Now, within this square bracket, I would need to complete the square in order to end up with this. Okay, so to get that part there that I've highlighted, I would need to complete the square for this. So I'm looking to halve the x coefficient. Now it's already been halved because I took the 2 out and I had to halve it to compensate for that, but I've got to halve it again now for completing the square. So you've got to be very careful here to include all the steps. So I've now got 2, okay, and I'm going to consider, I'll do it over here actually, what do I get if I do the perfect square? X minus half of 5 over 2 is 5 over 4. All right, so I'm going to do, I'll do it in a different color. So I'm going to do over here, x minus 5 over 4 all squared. Okay, and that gives me x squared minus 2 lots of 5 over 4, x, which is 5 over 2x, okay, which I was expecting, that's why I did it, to get the 5 over 2x. But then I have a residue left over of 5 quarters, negative 5 quarters squared, which of course is 25/16. Okay, so I've got a leftovers of 25/16. Okay, but what I need inside this square bracket is a half, and a half of course is 8/16. So what do I need to take away from 25/16 to bring it down to 8/16? Well, the difference between 25 and 8 is 17. Okay, so I need to take away 17/16. So this part here, okay, which I'll just highlight in there for you. So this part here, okay, from what I've worked out here, I can write as x minus 5 over 4 squared, all squared, okay, and then from that I've got to take away 17/16. Okay, now it's looking good because it's very close now to what we're aiming for here. In fact, we can just about assemble it now. So I'm going to go back to blue. I'm going to go down here and I'm going to write this as exactly as I've done there. So inside the square bracket, I have x minus 5 over 4 all squared, okay, minus 17/16. Okay, and there's my close bracket, and there's my equals 0. Okay, so my equation has literally been put into this form, and I should now state explicitly from here, so I'll go across here to carry on with my working, that P equals 2, Q equals 5 over 4, because the negative sign is given already, which matches here. So it's exactly as it is. It's 5 over 4, a positive number. And finally, R is equal to 17/16, because again, the minus sign is there for us. Had that been a plus sign, we would have needed to put R as negative 17/16, but it's not, it's just 17/16. So that has fully answered the first part of the question. All right, so it's a difficult question because you've got to make a start, really. A lot of people would look at that and wouldn't know quite what to do to start with, but it's always a good tip if you've got a fraction to multiply by the denominator first. Okay, so we now got to answer the question. Now, because of the use of the word hence, that means using what you've just done already, solve the equation. All right, well, hopefully by now you will know what to do here. Remember, we can remove the 2, because if we divide this by 2 and get rid of that 2 in front, we divide 0 by 2, we still have 0. So to solve the equation, okay, we can say that x, I'll do it over this side now. So this is solving the equation. I can say that x minus 5 over 4 squared equals minus 17 over 16 equals 0. Okay, therefore x minus 5 over 4 squared equals 17 over 16. Okay, therefore taking away the squared symbol, x minus 5 quarters equals plus or minus the square root of, now rather than write a big square root over the whole fraction, I'm going to write the root of 17 on the numerator, but just 4 on the denominator, because of course the square root of 16 is 4. Okay, and then I've just got to add 5 over 4 to both sides. So the solutions become x equals 5 over 4, okay, plus or minus the square root of 17 over 4. And one final step, which I showed you in a previous video, I could combine that into a single fraction, which equals 5 plus or minus root 17 over 4. Okay, now this could have been a calculator paper, and it could have asked you to give the answers to 3 significant figures or something like that. It could just as easily have been on a non-calculator paper, and it would have said leave the answers in exact form, or as simplified surds. Well, you can't simplify root 17, so that's it, and they're the 2 solutions. Okay, and if you were to substitute x in this equation here with that value, either 5 plus root 17 or 5 minus root 17 over 4, you would indeed find it works. Okay, you can try it on the calculator, but that is a difficult problem. It's one I invented, but I have seen plenty of exam questions where they ask you to arrange something into the form of completed square form without actually using the vocabulary, the terminology of completing the square. Okay, I hope that was of some help. Thanks for watching.